Today I will be talking about Android mutation testing. My name is Hazem Saleh. I am an Android architect in Nickelodeon and an open source committer and chief of issues. I would like to introduce myself for you. My name is Hazem Saleh. I have more than 12 years of experience in Java and mobile technologies. I have been contributing to Apache Software Foundation for more than 8 years of my life, working for open source software which targets a lot of customers around the world. I have been writing 4 books about web and mobile development best practices. One of my books was talking about unit testing, and it was one of the best-selling books in Amazon Deutschland and Amazon United Kingdom. I also have a lot of publications in the developer works and the zone about unit testing and development best practices. I'm also a frequent speaker in some of the Java conferences, such as Java 1, ApacheCon, GCon, Java Land. I also had a chance to be an expert group member in one of the Java technologies. And I have been working for IBM for more than 10 years, and currently I'm working as a mobile architect in Jacoco. So, what is the purpose of our today presentation? The first part of this presentation will show us the value of unit testing and why unit testing is very important for any corporation or for any company that really needs to make a professional work. I will show you how to make unit testing in Android using Android tools that we are having today, and how to measure the efficiency of your unit tests using the traditional techniques. I will also explain the current challenges of these traditional techniques and how can we overcome by using modern techniques like mutation testing and by applying one of the most popular tools in mutation testing, which is byte. Definitely all of these things will be will have demos, and I really want you guys to be focusing with me on these demos and to do it also by yourself in order to have a great benefit of this presentation.
Is there like a GitHub that we can?
Yes, I will show it to you when getting to it. At the end of the presentation, there is a quiz, a Java quiz. The one who will answer it will have this Android gift. I hope you will like it. And at the end of the day, at the end of the presentation, there is a room for questions and answers. I will be really looking forward to your questions. And again, I will be here until the end of the conference. I will give you my contact, so if you are having any questions, let me know. Okay, unit testing. A lot of people are talking about unit testing, but what is the value of unit testing? Why organizations have to spend money in order to unit test their applications? Because without unit testing, the developers will have to spend a lot of nights integrating the software. During integration time, the developers will not only spend the time in the integration defects between the components, but also they will have to fix each component defect, because each of these components were not tested, were not unit tested. So the integration experience between the whole components will be really complicated. You will have to focus on the integration defects and on also fixing every component defect in order to have a working system at the end. Adding to this, the developers will really have unmanaged number of defects, new defects or regression defects. Especially if your system complexity increases, especially if you are having a long-running system for many years, if you are having a product, this product can live for many years. If you don't have a repeatable test cases which runs every time on your application source code, you will not know that the defect which you faced yesterday will happen tomorrow or not, because you don't have any automated way to see how good your code is. Given the complex integration, given the unmanaged number of defects, usually the application quality will be low. Even if it is working, will be definitely low. Because you do not guarantee if new updates to the application will cause effects, or if some conditions happen to your application, like network unavailability, like whatever condition which can happen, you don't guarantee if your application will behave correctly or not. And the organization will have to pay a lot of money in order to make a new release for the product that is already in development today, or for an update release to fix some of the current products defects that is currently existing today. So it is a very big lose situation for the developers, which will have to spend a lot of time in order to integrate these components, and also for the organization, which will have to pay a lot of money for testers and for having more quality checks before launching the product. All of us knows what is unit testing. For me, unit testing means if you are having any piece of code, this piece of code can be a function, can be a class, can be a static block, can be an instance block. For every piece of code that you are having, there should be another testing piece of code which tests the original source piece of code according to some specification. In order to make good unit testing, you have to test every component in an isolated way. So if you are having a component X which depends on component Y and component Z, you have to mock component Y and component Z in order to focus on unit testing component X very well. One of the most bad practices of unit testing is that the guy tries to test everything in the unit test. This is wrong. Unit test should focus on one and only one component at a time. He doesn't care about integration issues. He just cares about the behavior of the specific components that you are testing now. If we really implement proper unit testing strategy like TDD or generation unit testing technique, buggy components will appear in very early stages in the project. You will see what's going on. Yes, this video player component looks like it will be buggy one, so we have to fix it before the axe falls, before the actual production release. In unit testing, there are some terminologies such as test suite, test case, test function. Test suite is a group of test cases, and a test case is a set of tests which verify the system component according to the system specification. Okay, now we will write our unit tests. How good are we? When do we know that we are writing good unit tests or not? Good unit tests should be repeatable. Repeatable here means if you are running your test cases for X amount of time, for 10 times, it should always give you the same results. It should not succeed one time, fail other time, succeed, fail. There should not be flaky tests. You should avoid having these flaky tests, which does not have any predictable behavior. Your unit tests should be repeatable. This is very important in order to have quality unit tests. They should be automated. If you are having your unit tests which are not automated, you will not really have any mechanism to make sure that the developers are already running the unit tests or not. So it is really recommended to have your unit tests automated, make them integrated as part of continuous integration tools like Jenkins or Hazem. How many of you using Jenkins or Hazem? No one is using Jenkins? Yeah. So it is really great, really important to automate the running of these unit tests in Jenkins in order to make sure that unit tests are running periodically and the system is going fine. Unit tests should be fast. You should not make I/O operations in tests. If you are having a class which makes an I/O operation, try to mock the I/O operation in order to make your test as fast as possible. Unit tests should not take hours for running. It should be easy to run. It should be easy to understand. Everyone of the team can understand it. The question here is, how can we make our unit tests easy to understand? There are a lot of techniques which you can apply. I will show you a demo of how to write easy to understand unit tests. One of these techniques is to use the given, when, then pattern. This is one of the patterns which was introduced by Martin Fowler in order to give you the ability to write clean unit tests, to describe when your object has some specific case, giving a specific case for your object, when a specific method in your object is called, then my object should have X and Y and Z. To have a structure for your unit tests. Finally, it should be incremental. This is very important. Incremental here means unit tests should be active. Should be like the source code that you are developing every day. For every line of code you are having, you should have a new line of test to verify that your code is working fine. Not only this, but also if you are having a defect today in one of the components that you are having, you should create a unit test which replicates this defect in order to avoid seeing this defect again in the future. This is very important discipline. These 6 principles are very, very important in order to really write great unit tests which can live with years with your products. Okay, what about unit testing in Android? How can we make unit testing in Android? There are a lot of great tools in Android which allows us to make unit tests. One of the most popular tools is JUnit. How many of us use JUnit? Wait. And Mockito. How many of us use Mockito? Yes. Why JUnit is the test runner, is a test framework, which will allow you to write your test cases. What is the value of Mockito here?
For network calls, like when we do retrofit calls or something,
Exactly.
we make mock calls using this.
Exactly. Again, like I told you before, when talking about the definition of unit testing, in order to unit test a component X, which depends on component Y and Z, you should mock component Y and Z. In order to focus your test logic on component X. This is why Mockito is here very important, because it will allow you to mock the dependencies of your class that you are testing today. It's very important to use Mockito, and I will show you an example. However, sometimes JUnit and Mockito are not enough. If you are having static methods in your code, if you are having final methods or final classes, if you are having private methods, unfortunately, Mockito cannot mock all of these cases. So in order to mock these cases, you need to use PowerMock, which is another good tool in Android that allows you to make sophisticated mocking. What about unit testing? The classes which have rigid dependency on Android SDK, like views, like fragments, like activities. How can we unit test them? Using Mockito, you can unit test them. However, you will have to mock all of the Android SDK APIs, which can take a lot of time from you. So what is the solution here? Thanks to the open community, we are having Roboelectric. Roboelectric gives you this ability. It mocks all of the Android classes by creating something called shadow classes. And it really adds a great power to your test. If you wanted to unit test your views, your fragments, or activities, you can definitely lean on Roboelectric, and it will give you a great result. However, The best practice here is very, very important. Don't use roboelectric unless you need it. Again, don't use roboelectric unless you need it. Roboelectric is a great tool, but it is not for free. It will make your tests more slow. So if you really don't have a class with a huge dependency on Android SDK, please use Mutation only. Please don't use roboelectric, because sometimes in some projects, some Android projects, unfortunately, guys are using roboelectric every time, even if they don't need it. And at the end of the day, the performance of their unit tests goes down. Sure.
Do you believe that like a good project can be done without roboelectric in general? Like, if you separate your business logic enough from that?
Yes, but if you would like to unit test the view or activities logic, if you don't have passive views, in this case, you will need to lean on roboelectric. It depends on the agreement, the team agreement. Some teams agrees on unit testing everything: the views, the presenters, the interactors, the services, all the layers that you are having in your application. Some teams say, hey, no, I will not test the views. I will just unit test the logic, the presenter code. In my opinion, the best strategy is to test everything, even the very small pieces of views. If you are having any certain condition, it should be unit tested, because you don't have any real measurement if you didn't unit test this. But again, the team decision is very important here, because unit testing is not an easy task. It is a task which needs commitment from all the team players, from all the team members. If they are not committed to it, they will not do it. So we have to agree as a team on the unit testing strategy from day zero in order to have this long commitment on the long run. Understood? Okay, now we write our unit tests. Are we good? Unfortunately, sometimes some teams just write unit tests without measuring anything. They say, hey, I'm having unit tests here. This is a class and this is a unit test. Hey, I did my job. No, unfortunately, you didn't do your job, because you didn't measure the amount of source code tested. You didn't know how many statements are unit tested, how many branches are unit tested. What is the percentage of branches tested? What is the percentage of functions tested? All of these things are called code coverage. Code coverage is your metric, is your quality metric, is one of the quality metric which shows you how good your unit test is. There are some coverage criteria, such as the statement coverage, which measures the amount of unit tested statements; function coverage, which measures the amount of unit tested function; and finally, the branch coverage, which represents the amount of branches of each if statement or each control structure covered. Fortunately, in Java, there are a lot of good tools which can give us code coverage. I will show you now a demo about one of these tools, which is called Jacoco. Jacoco is a free code coverage library for Java. And fortunately, it shows you the amount of statement coverage, the amount of branch coverage, and the amount of function coverage. The other good piece of news is that it is totally integrated with Android applications. I will show you now an example. You can use Jacoco very easily with Creative, with Android Creative. And all what you need to do is 3 steps, which I will show you now. just determine what are the build types you would like to be covered. If you are having debug build type, if you are having staging build type, if you are having production build type, you have to choose which one you would like to have good coverage. You can choose all of them definitely. After that, you just import the plugin into your build file and configure it with your Java source. I will show you now that. So just download this sample in GitHub. This is one of the samples which I have developed to show the technical community a way of implementing the MVP pattern, the model view presenter pattern. This is one of the structural patterns for Android applications. And it also includes JUnit, Mockito, unit tests, and Jacoco code coverage to show the community how to start applying these principles in their applications. Let me show you this application and give you a little bit overview about it. First of all, let's run this application, the Dagger sample application. This is the home page of the application. It just lists some of the GitHub repositories of Google. You know, Google is having some contribution in GitHub, so all the repositories of Google will be shown here. You can click any of these projects to know some description about it. You can open the navigation drawer for going to some sample page, which can show you some information about a weather. You can here specify the city that you would like to get its weather and say, hey, show me some information. It will give you some message and it will give you the current weather in this city. This is just a very simple application, but it really tries, the main value of this application is not the functionality, it just tries to show you how to structure your application using the MVP pattern and using Dagger 2 and how to unit test this and measure this as well. So let's go to the application source code. This is the application source code. Are you seeing this very well? Okay. This is the view layer. The view layer here contains two main views. The repo list fragment, which we just see now, which shows Google GitHub repositories. As it's shown here, this is a very simple fragment, which implements a view interface. In order to make a valid MVP implementation, your activities fragment should implement a view interface. This view interface will decouple the presenter that you are having in your application from the activity of fragment code. So if we go to this view interface here, label list view interface, it just has some view APIs, show label list, show error. This view interface will allow any component, any other component to communicate easily with your view without having a direct dependency on the view implementation. This is very important discipline in order to implement MVP, to have a view interface which highlight the APIs that you want the presenter or whatever component to use in order to interact with your view without knowing if you are having fragment or if you are having an activity. So here's the repo list fragment. Just call a presenter method, show request a repo list, get me the repository list of Google, and returns, the show repo list will be called, and if there is an error, the show error will be called. Very easy and simple pattern. Let's see the presenter layer. The value of presenter layer in MVP is to make your view class very small. Is to make your activity class very small, as much as you can. The presenter will interact with the services, with the different services, and will just get the data from the services and give it to your view in order to display this information. So the main value of this pattern is to make the view as dumb as possible. The view should not have any logic. Just route your call to the presenter will call the services, service will return the result to the presenter will give it to the view. So here, the presenter should also implement a presenter interface. Why? Because you might have different implementations of presenters. Again, this is very simple presenter. You just have request repo list information. And finally, it calls interactor. What is interactor? And why don't we call the service API directly? Again, the MVP is a design pattern which can have different implementations, and you really need to pick the right implementation which fit your application needs. What I'm trying to say here in the GitHub sample, I'm trying to give a generic architecture, generic pattern which you can reuse in your applications very easily. One of the values of the interactor pattern here, which is under the interactor package, is to orchestrate the service calls. So, if you are having some services and you really want to minimize the amount of code that you will write in your presenter class, you need another layer which orchestrates the code with the service. Talk with service 1, talk with service 2, get the result of service 1, get the result of service 2, put them together, make some formatting, give them to the presenter, which will pass it to the view. So if you are having this case, I highly recommend you guys to use the interactor layer to decouple your services from your presenters. However, if you are having one service per every function, only one service per every function, I do not recommend to have the interactor layer. You can just make your presenter class call the service APIs. Again, it's about your project requirement. It's about your project requirement. This is very important. There is no solutions that can fit all the sizes. What I'm trying to present here is the generic solution which you can customize or modify as much as you can. Here in the here in the main interactor, there is a get repository list. It finally called repo list service, which implements Rx. Rx is how many of us uses Rx? The active. Yeah, Rx is this very simple, which allows you can have a neat way in order to retrieve content from HTTP services. So here, in the repo list, we are saying get and subscribe on the thread scheduler. And when you return, when you are having the repository list, just return it to the listener. The listener is here, is implemented in the presenter, so that repo list retrieval success. If we go to the repo list service, it is very easy service here. You see, interface that will allow you to access the result very easily, as we see here by just writing this line of code. Just one line. the declarative way of HTTP services access. So the result will be returned to the presenter here in the presenter embed, and the presenter will call the review interface saying, hey, show me the repository list, whatever Android component, and it will handle the UI display. This is how the MVP pattern should be implemented. Very easy. Have these layers in order to have very small contributions from your team members. How can we unit test this? Inside the test directory, you will find the unit tests. This is here an example of unit testing the wizard presenter interface. The wizard presenter, again, is just like the repo list presenter. It just talks with main interactor, which calls the wizard service in order to return the wizard information of the specific set. Here, let's see how we structure our tests. What is the best practice of structuring your test? We are using Mockito. We don't use Recollected because the presenter here doesn't have any dependency on Android SDK. It just have dependency on what? Interfaces. No real dependency on Android APIs. So what we have here is the wizard presenter instance that we are unit testing, and the presenter object, the presenter object has two dependencies, one on the interactor and the other one on the view. So we need to mock these two components. Understood? You remember in the beginning of the session when I said unit testing should focus on testing every component in an isolated way. This is the example here. Here we have a wizard presenter object which depends on main interactor and main view. We should really mock the main interactor and the main view. If we didn't mock them, we will not really make a correct unit testing for this component in an isolated. After that, we instantiate the wizard presenter embed, giving him the mock main view and the mock main interactor. We call here some mock interactor method, which tries to add some behavior here, which tries to mock the get information, get wizard information API, get repo list API, get items API for the success and failure conditions. Because I don't want to have HTTP communication. This is why we should mock the object. In order to properly mock the object, you need to understand and study the actual conditions of the object that you are really trying to mock in order to make proper mocking. After that, we instantiate wizard presenter embedded. And now we are having this object. And before, annotation here means this function will be executed before every test function we are having. Okay, understood? Any questions so far? Here, what is this way? If you see here our test, request information. When user name and city are valid, should return information. What is this methodology? And why we are applying this methodology? This is the given when then methodology. This is one of the ways to structure your test. One of the ways, one of the techniques. There are different techniques like that. Triple A rule, there are a lot of techniques, but the given when then is, I think it is more descriptive way. Here, it will try to say, given some condition for your object or your object dependencies, when a certain method is called, this is the method that you are testing, that you are unit testing, then expect your object to output X and Y and Z, or your dependencies methods to be called. Any questions here? So, request information here is, we are assuming here that there is a valid city and valid username, and we are trying to request the weather information. If we try to request the weather information for a valid username and valid city, then the main view should have some successful results. Not only that, but also, when you make unit testing, you should really test boundary conditions. If you don't test the boundary conditions, then this unit test will not be effective. So here we need to unit test the boundary conditions for empty username, empty city. So here we will try to simulate where the main view have empty username, and we are having valid city here, and we are requesting the weather information, then the username error should appear. Not only that, but also when the city is empty. When the city is invalid, you should, before writing this unit test, don't start writing code. Don't start writing code before, if you want to write unit test. Just think for 10 minutes. What am I trying to test? Just write it in a paper. I'm trying to test the weather component. Okay. What are the functions that I'm targeting to unit test? Just write these functions. What are the happy path scenarios? Write down them. What are the edge cases? Write down them. After having this list, writing the test class will not take more than 5 minutes, because you know now what you are going to test. You have a question here?
Yeah, I mean, I was going to ask, do you believe that you have to actually write the test before you start writing your actual code implementations? Or?
You are talking about tested revenues, right?
Yeah.
It depends. It depends on the project nature. I really prefer tested revenue development. If you are having a greenfield application, if you are having an application that, hey, let's write this application from scratch. Let's start from day zero. So for greenfield applications, I totally agree with that. But in some cases, you may come to an application that is already developed by a team. And sometimes you may not have unit tests in this project. So in this way, you will need to have to implement the traditional unit testing techniques to try to reverse engineer, to understand the codes, the sequence of codes from the non-unit tested objects, and write unit tests for them in order to just make sure that these components will not break if some change happens. So in real world scenarios, theoretically speaking, test level is the best approach, theoretically. But again, practically, you should assess the current situation and choose the best tool which will fit in this situation. This is a very good question, by the way. Thanks. So, now we write our unit test. How can we measure it? We need to use code coverage tool like Jacoco, right? So how can we configure Jacoco? Very simple. Go to the build to created file, the application build to created file, and here specify what are the build types that you would like to have code coverage on. Here we decided to have it on debug, so we just said test the coverage enabled to true. And try to separate your configuration in isolated files. One of the bad practices is to have all of your configuration in one file, in the build or graded file. Fortunately, graded is an advanced tool now, so you can isolate your configuration in external files in order to have a maintainable build script. So here, if we go to Jacoco.graded file under config, this is how we configure Jacoco. Well, what you need to do here to specify Jacoco version and to write this Jacoco task. The source code that you would like to cover, inside the source code that you would like to cover, here specify the directory of the classes that you would like to see, and don't forget to specify the classes that you would like to exclude from the test coverage. Oh, you just told us in the beginning of the presentation, we should test every line of code, right? Yeah, but sometimes you might have some frameworks like Dagger, for example. Dagger generates some classes, some meta classes, So you should not really be worried about these classes. Sometimes you may have model classes. Model classes here means classes with just getters and setters. So in this case, yeah, if the getters and setters bit doesn't have any logic, then this is fine. Sometimes you may have simple exception classes, just exception class which extend exception, doesn't have any logic. So this exclude list should be determined by the team. The team should decide what are the classes that we should exclude. Generally speaking, you should not exclude anything other than plain old Java objects which just have getters and setters, exception classes, and generated classes. And here finally you specify your reports. Here we would like to have XML report and HTML report. Here you guys, if you would like to start with Jacoco, just go to the project and copy this graded file and start to playing with it. It is very important to start doing the stuff by yourself. Just copy the project, have a vote from the project and do your stuff. It should be really good. And feel free if you see any issue in the sample to create a pull request, and I will definitely run. So let's now run this. So here we create a Jacoco test report task. Let's run this Jacoco test report task. In order to run it, we will write graded W clean Jacoco test report. Just to call the graded task. Here Jacoco is running the unit tests. So we'll try to run the unit tests and we'll look at two classes. Hey, yes, this class is covered, this line is covered, this function is covered. This if condition is, this if condition has only one class covered, if true is covered, but if false is not covered. It's trying to get all of this information for you. And if we go to the build here, go to app build in order to see the generated report. Go to app build and open reports directory, open Jacoco directory, HTML, index.html. Just open this in the Finder. And here we see the report. As you see, Jacoco report is really simple. And you can show to your manager, you can show to business people who may not have a very large technical details. Just show him, hey, this is the classes that we are having, this is the code coverage, this is the packages that we are having. If we go to the detail of any package here, we can see the classes, we can see the methods, line by line. If there is something not listed, it will be shown here as red. Very simple report, and you can. It is really a good practice to have this Jacoco report as part of your Jenkins configuration. So every day, your team can see the result. of unit tests. How good are we today? How good are we? What is the amount of unit tested code that we are having today? Great. This is really great so far, right? We are having 100%, right? Are we okay if we are having 100%? Are we really confident? Can we say, hey, our code is now bug-free?
Bug could be in the code itself.
Sorry?
Bug could be in the code itself, like runtime.
Yes, but if we are talking about the coverage.
It doesn't seem to our integration side.
No, just focus on the component, every component. So now, can we say that every component now is 100% covered? Yes, right? Okay. I was saying yes in the old days, by the way. I was like, I had this answer until I know that the answer is no.
Yeah, I'm looking at it and I'm saying, isn't it saying missed instructions? What does it mean when it says missed instructions?
Missed instruction here is trying to say here
That we have
this line is not covered. But this is not the problem. I will show you now the
We
problem.
excluded few files.
No, I'm just trying to these files, which Jacoco is saying, hey, you are having 100% or 99% coverage. The answer is no. The answer is, I will show you who I am. I will show you. There are some challenges. Jacoco gave you something called traditional code coverage. If you don't have unit test at all, you should have Jacoco first. You should have the traditional code coverage first before going into the next step, which I will be talking about right now. The traditional code coverage is good, but it is not perfect. It is not perfect. Why is not perfect? Because it just measures the amount of executed lines of code, just the amount of lines of code or amount of functions or the amount of branches. It doesn't have any mechanism to detect the code fault. It doesn't have any scientific way to know what will happen to the code if some line of code is commented. It doesn't have this mechanism. What will happen if some condition is changed? What will happen if some value is reverted? No scientific way. It depends on everyone verification. It doesn't, traditional unit testing doesn't really measure how good your unit tests are, unfortunately. Okay, how can we measure this? How can we do that? This is the value of mutation testing. This is why mutation testing come to the scene very, very strongly. You say, hey, traditional unit testing doesn't detect code faults. So how can we detect code faults? Mutation testing is trying to solve this problem by trying to seed your application source code with different mutations. These mutations can be like what? Can be like changing some mathematical operation. If you are having integer x equal y plus z, you will say, hey, integer x equal y minus z. What will happen? If your code, if your unit test succeed, oh, this means that, hey, the mutation which changes this line of code could really break your unit test. Your unit test could not detect it. So the mutation will be left, and he will say, hey, this unit test is not good. You need to modify. If he tries to make another mutation, like, for example, converting multiply by, for example, and your unit test failed, this means that your unit test is great because it could detect the code fault. In mutation testing, the quality of the test can be measured by the percentage of killed mutations. The mutation will be killed if your unit test failed. Because if your unit test fails, this means that the mutation could not affect your unit test. Your unit test is really great. It can really fail. When this guy, this mutation tries to play with your source code. It is a really brilliant idea, very brilliant idea. What are the examples of these mutations? These mutations can be like negate condition mutators. So if you are having, if x is less than or equal y inside the code, it will try, one of the mutations will try to say, hey, this is if x less than or equal y, it will try to change it if x is greater than y. Not only that, but also there are other ones. If you are having x equal I plus plus, this is a whole increment mutator. He will try to modify it to be x equal I minus minus. Not only that, but also there is invert negative mutator. So if you are having variable x, integer x equal minus I, he will try to say, no, variable x equal I. Hey, your unit test will succeed or will fail, will fail because there are very, very good verification mechanism here. Mass mutator, he will try to change the mathematical instructions to the opposite. Return a value mutator, this is very funny mutator. So if you are having a function which returns Boolean value, for example, and you return true, he will try to change it to false. Instead of returning true, he will try to change it to false. There is also void method call mutator. This is also an interesting one. If you are having a function, some function, which does some stuff, and this function is calling another void function, and then return, and doing some stuff, he will try to comment out, he will try to remove the call to the void function to see what will happen to your code here. This is very important. Why? Because sometimes a developer can, by mistake, remove a line of code. So if a developer removes a line of code, will your test really fail? Or will it succeed and no one will know what's going on until we go to production, assuming that the QA will not catch it. Okay. The operation of seeding mutations into your code is a very expensive operation. It's not easy operation. This is why there are a lot of trials. In the open source community, one of the great values of open source community is that you are having a lot of solutions. Every now and then you are having solution. People in the open community are trying to do their best in order to have good solutions for the community. So we have a lot of mutation testing tools in Java. However, byte is a great one. Why? Because it is fast. Some of these tools, unfortunately, are slow because he is trying to mine your code and to change the byte code of your source code in order to change the instructions. Byte is really great because it is fast. It's compatible with Java built tools, compatible with Ant, Gradle, Maven, and it really has active community. And at the same time, it provides you easy to read test reports. I will show you now these test reports in order to understand.
Sure. So another question, how, like, for the mutation testing, how, because technically unit tests, like, how much do you change for it to fail? Is it any line?
I will show you now in the demo. I will show you now.
Oh, I guess this is more like just like an existential unit test question in general. Like, is it supposed to fail by changing any line, even though that line doesn't just changes the way your business logic works, or something like that?
Again, this is a mutation, random mutation. He will try to remove a line.
Okay, so it's an actual mutation.
Yeah.
That will affect whatever.
Yeah. He doesn't know if this line is important or not important to the business. Sometimes it may be important, sometimes it may not be important. In the demo now, which I will show you, we'll see an example here. Okay. So byte is, again, it has a graded plugin, which is available here, guys. You can go ahead and download it if you are using in Java project. It works fine with Java graded projects. However, unfortunately, it is not working very well with Android applications. So one of the great Polish guys in the community created a fork of this plugin. His name is Coral, and make the Gradle byte test plugin, which works very perfectly on Android. In order to configure this plugin, you just need to include the plugin version, the plugin name and version into your dependencies, and apply the plugin. After that, you need to, just like we had done with Jacoco, you should do it with byte test. You need to include the classes that you would like to be covered, to be mutated. Exclude the unnecessary classes. It specifies a number of threads. Usually, you should have a good amount of number of threads, because this operation is heavy operation. So if you have good number of threads, usually the mutation testing will be faster. So here you specify the number of threads. 4 is a good number. And finally, you specify the output format. What is the output format of your byte test? Let's see. After that, you will run it and to see the result. Let's see here what will happen when we run byte mutation testing. Let's first of all let's see it in our code. So let's go to the build, the graded file. Here we specify the byte testing plugin in our main build graded file, and in the build graded file of the project we specify here byte graded, which contains the byte graded configurations. Open this file. Here we configure what are the classes that we would like to be covered, what are the classes to be excluded, what is the timeout factor. If you are having some classes which may have some delay, you can specify this timeout factor, and finally, what is the output format. Let's run Jacoco unit test on Jacoco mutation test on the byte mutation testing on the classes which Jacoco said, hey, this is 100% covered. Let's see. So in order to run it, we will say graded W clean byte test. This guy is doing much effort, more effort than Jacoco. Jacoco just tries to see the amount of cover. Here, this guy is trying to inject mutations into your code and see and measure the amount of killed mutations. So here we can find the build here under the report under build. Oops, byte test debug. Open index.html here, reveal in Finder. Open. Oh my God. This is the byte test report. Byte test report is trying to say, hey, if you apply line coverage, the traditional line coverage, you will find this package 100% covered. But the reality is no. It is only 50%. It is vague unit testing. The developers didn't take care about doing enough verification for the unit test. Let's see what happened. Let's open this. This is a wizard implement, wizard presenter input class. Let's open this. Here, it's trying to say here, hey, this is the green line. The green lines here mean, yes, this is great. He's trying to do some mutation, but it works fine. But in the red lines here, it tries to do some mutations, but it fails. Let's see here what happens in the show busy indicator and hide busy indicator. He's trying to here remove a call, a complete call to show busy indicator. And nothing happened. Your unit test succeeded. He really remove a line of code here. Remove the show busy indicator, and hey, it works fine. No worries. We are fine. We are great. We are 100% covered.
It can be kind of dead code.
Sorry?
Yeah, the dead code.
I mean, it can help you detect that code.
Yeah.
If there is some code.
He doesn't know. It is a tool.
Yeah.
You are the guy who knows the stuff, who knows the business, who know what are the important lines. In this case, this is really an important line. Because some guy can remove the show busy indicator. So when the synchronous operation happens, no show busy indicator will appear to the user. The user will feel that the application is stuck. Actually, the hide busy indicator here is an issue. So if a guy tries to just remove the hide busy indicator and this application go to production, the busy indicator will be always showing. It's showing, hey, what's going on? We are 100% covered. No. Unfortunately, no.
Should we write a if condition?
Sorry?
Should we write a if condition?
I will show you how to fix that. But this demo is trying to prove something very important. If you are having 100% coverage in Jacoco, this doesn't mean that you are covered. Be humble. Say, we are improving. We are not perfect yet. We are not perfect yet. So here, let's go to fix this. Oh my God, 100% and 50%. This is scary. Because your manager can know this information. Hey, you tell your manager we are 100%, and he can say, hey, our team is 100%. At the end of the day, what's going on? The show busy indicator is the application is stuck. The application is crashing. The components are not tested well. So let's go to the test to fix this. Here in the weather presenter test, what we were doing is just it's checking the result. It's checking that when the weather information is being requested, the show result will be called. We didn't verify that the show busy indicator or the hide busy indicator of the view class will be called. This is very important to make sure when your test function runs that your object will output something, or the dependencies of your object will have some certain codes. You should verify these certain codes in order to be in the safe side. So here we will try to fix it. We'll try to have here verify. So we'll verify that show busy indicator and hide busy indicator is being called for every request information. We will uncomment this here also. We will uncomment this. And this one. Now we try to verify everything. In order to really write a great unit test, the general rule here is verify everything. Verify every line of code. Don't say, hey, it's enough. I already verified the variable instance state. This is good. Why should I verify the mock object? Why? This is good. What? I did a good job. No. You didn't do a good job. In order to do a good job, you need to verify everything. Because this is a software, and testing software is really hard. Really hard. Unit testing is a very important activity. It should not be considered as a secondary activity to projects. It is a primary activity and very important. Its importance is much higher. Much higher. Because if you write an application which crashes a lot, unfortunately the corporation will lose a lot. So let's now rerun Jacoco byte tests to see if this will fix it or not.
what's the command for that again?
byte, okay. Upgrade W,
Okay.
clean, yeah, BI test. BI test. So let's now go.
There are no survivors now.
Sorry?
Now there are no survivors.
Yeah. Now what? Mutation testing gave us 100%. Now you can say, hey, I'm confident. I'm confident. Something may happen, definitely. So this is software, but at least scientifically you can prove that you are. Okay. So this is all about my today presentation. I really hope that it could have more hours because this topic is big, very big, and it is very big and very interesting. Very interesting topic. So this is the quiz of my today's presentation. I would like you guys to know we are having here a base class and a child class. The one who will answer this will take this Android gift. We are having integer value equals 6. And static block. This static block is trying to say value minus 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 value. And inside the instance block we are having value equal value plus 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 value. And in the child class we are extending the base. In the static method we are saying value equal minus minus value minus value minus minus. And in the instance block we are saying value equal plus plus value plus value plus plus, and we are saying here child equal new child, child with value. What is the value of value? Just think about it. It's not easy.
Is it not error?
Sorry?
Compile time error?
Compile, no, it will not compile time error. It will compile correct.
I mean, we could just use child class name dot value.
No,
it's
it is the same,
okay.
the same class.
6?
6? Who will say 6? Okay. What is the sequence of calls here? Yes, it is the right answer. What is the sequence of calls here?
Decrementing and then subtracting and then decrementing again. But then
Yeah.
you are doing exactly the
Which
opposite.
block will execute first?
First the base. And then the child will do exactly the opposite. So at the end you should have the original value.
Thanks so much.
Thank you.
Thanks so much. It's very important to always think about Java expressions. It is always tricky. It takes me a lot. So we are having only 5 minutes. This is my Twitter handle and email. Feel free to contact me anytime, guys, if you have any question. Any questions you are having in these 5 minutes? Sure.
So in generating mutations, is it generating every possible mutation for that section of code?
It has some of the predefined mutations, and you have the ability also to specify what is the list of mutations that you would like to have. There is no way today to generate all the possible mutations. I think this is impossible. But he has really a great set of mutations which can make you feel confident about the whole process. Like the incremental mutator, the math mutator, and etc.
Can we run these test cases in release mode with program or something like that?
You can what? Sorry, what?
Can we run the unit testing in release mode
Yes.
with program enabled?
Yes, this is actually Brugard enabled. This application is Brugard enabled.
So will they become part of the APK?
No, unit tests are not packaged in your APK. Your unit test, again, unit test is a tool which verify the amount of tested lines of code that you are having today.
The code that we write, the test, which is under the test directory, so it won't be part of the
Yes, yes, the test code is not part of the LD. You don't need it. You don't need it.
Does Jacoco run random mutations for each launch, or they are the same line? Same set of mutations? According to rules, of course.
He is trying to apply all the mutations that you specify. This is what we are demonstrating today is just the out of the box mutations. You can add more mutations in the configuration files of BIT. You can include more and more mutations. Any questions? We are still having 1 minute. Okay, thanks very much. I hope you enjoy today's session. Thank you.
Thank you.